Welcome back, geometry students. To find the value of x, I know that the 6 angles of a hexagon must add up to 720 degrees. So I set 162 plus 90 plus 98 plus 135 plus 140 plus x equal to 720. Combine your like terms and solve for x. X is equal to 95 degrees. Remember, these figures are not necessarily going to be drawn to scale. And also remember that if you want to pause this video at any point to work a problem out yourself, feel free to do so. This problem is completed a similar way. Since there are 6 angles on this hexagon, I set the 6 angles equal to 720 degrees like I did before. X minus 30 plus x plus 2 plus x plus 12 plus x minus 20 plus x plus 24 equals 72 degrees. Combine your like terms and solve for x. I got x is equal to 122. To find the measure of each of the angles, plug in 122 for x. This is what I got when I plugged in 122 for x. If you want to check your work, add up all 6 of the angles and make sure they add up to 720 degrees. Using our formula for the sum of the interior angles of a polygon, I found that a regular pentagon has a sum of 540, a regular dodecagon has a sum of 1800, and a regular 20gon has a sum of 3240. To find one interior angle, I'll simply divide 540 by the number of sides, and I get 108 degrees for each angle in a regular pentagon. Since there are 12 angles in a regular dodecagon, I divided the sum, 1800, by 12 and got 150. I did the same thing for a regular 20agon. 3240 divided by 20 angles equals 162. For the exterior angles, remember that the exterior angles add up to 360 degrees no matter what the polygon is. So to find the measure of one exterior angle, you can divide 360 divided by the number of angles. Notice also that the interior and exterior angles are supplementary. So another way to find them is to simply subtract the interior angle from 180 and you'll get the exterior angle. This time, instead of knowing the number of sides, we know the measure of one interior angle. So I set up my equation, n minus 2 times 180 divided by n, and set that equal to 56. You're going to have to use some of your algebra skills. Check your work with mine. You should have gotten n is equal to 15 sides. I'm going to do the same thing for b and c. Set n minus 2 times 180 divided by n equal to 165. Multiply by n on both sides. These n's cancel out. Next, I distribute the 180 to everything inside the parentheses. 180n minus 360 is equal to 165n. Subtract 180n from both sides, and I get negative 360 is equal to negative 15n, which means that n must be 24. For the last one, I got n is equal to 9, so this must be a nonagon. To find n if we're given an exterior angle, the work is a little bit easier. All I have to do is 360 divided by 22.5, and that'll give me n. I found that D was a 16gon, E was an 18gon, and F was a 20gon. Remember that the mid-segment of a triangle is the segment whose endpoints are the midpoints of two sides of a triangle. Since this segment is congruent to this segment, this is a midpoint, and this segment are congruent, so this is a midpoint as well. The rule is that the mid-segment is equal to half the length of the side that it's parallel to. So for the first one, x is equal to 11. For part B, x is equal to 30. In a trapezoid, the length of the mid-segment is equal to b1 plus b2 divided by 2, where b1 and b2 are the bases of the trapezoid. I plug in 27 for b1 and 41 for b2 and divide by 2. I get that the mid-segment is 34 units in length. Part D, 5 plus x divided by 2 must be equal to the mid-segment, 8. I multiply by 2 on both sides, and I get 5 plus x is equal to 16, so x is equal to 11. Part C, I use the same formula. Base 1 plus base 2 divided by 2 is equal to 2x. If I simplify the left, I have x plus 9 is equal to 3x. So x is equal to 4.5. If I plugged that in, I'd find that base 1 is equal to 4.5 times 2, or 9 units. And the mid-segment is equal to 13.5. I assign the first point to be x1 and y1, and the second point to be x2 and y2. Using the slope formula, y2 minus y1 divided by x2 minus x1, I got that the slope is 3 over negative 5, or negative 3/5. The formula for the endpoint, the midpoint, is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Plugging in my x's and y's, I find the midpoint is negative 1/2, comma, 7 1/2. For the second set of points, I found that the slope was negative 2, and the midpoint was 1, comma, 3. Determine if the two lines identified by these points are parallel, perpendicular, or neither. To determine this, we have to find the slope of each of the segments. If they're parallel, they'll have the same slope. If they're perpendicular, their slopes will multiply to negative 1. Another way of saying this is they have opposite reciprocal slopes. If neither of these are true, then we'll say that the segments are neither parallel nor perpendicular. For part A, I found 6/5 and negative 5/4 to be the slopes of the two segments. Since they're not the same slope, they're not parallel. Since the slopes are not opposite reciprocals, they're not perpendicular. So they are neither parallel nor perpendicular. Part B, the segments are also neither parallel nor perpendicular. Interestingly enough, the third set of points is also neither parallel nor perpendicular. First, I'm going to determine whether the quadrilateral is a parallelogram. I'm going to do that by finding the slopes of the 4 sides that make up the quadrilateral. Since I do not have 2 pairs of parallel sides, this is not a parallelogram. Since I do not have 1 pair of parallel sides, this is not a trapezoid. Therefore, I can conclude that this is simply a quadrilateral. I hope your studying goes well. If you have any questions, feel free to email me at amy_j_bierman@mcpsmd.org.